In this video, I'll show you how to express a rational function as a sum of partial fractions to integrate. This is question 2. The technique used to convert a rational function as a sum of partial fractions is summarized below, and this method only applies if the highest power in the numerator is less than the highest power in the denominator. The function that we'll be integrating here is the following, and the first thing that I'll do is factor the denominator. Notice that this is a cubic function at the bottom. So we can start off by factoring out an x from all three terms because all three terms share at least one x. If we do that, we end up with the top part stays the same. The bottom part becomes x times x squared minus 2x minus 3. You'll notice now that this quadratic trinomial is also factorable. You can find two numbers that multiply to negative 3, and those two numbers can add to negative 2. Can you think of those two numbers? I'm thinking of negative 3 and positive 1. So let's rewrite this in factored form. X bracket x minus 3 and x plus 1. And we'll find the integral of this function dx. Since there are three factors in the denominator, you'll have to rewrite this in the following way. Here's how. A over x plus b over x minus 3 plus c over x plus 1. We have to find a, b, and c that when you multiply all three of these terms together will give you back the original. The next step is to find a common denominator amongst all three of these terms. So we'll multiply these two together, then cross multiply the denominators with the numerators. Then you'll do the same thing with the last term. So multiplying these two together, we end up with x over x minus 3, a times x minus 3. And mind you, a, b, and c are all constants. They are not variables. X times b is bx plus this part. And now we'll do the same thing. Multiply these, and then cross multiply. Where we end up with. Now that you have your equation set up this way, you could expand this a little bit. And if you do that, you'll end up with the following, where you have x plus 1 times a bracket x minus 3 plus x plus 1 times bx. So let's rewrite that. If you've done it correctly, it should look like this. Now, since the denominators are the same, we can disregard them when it comes to solving for a, b, and c. So we have 5x plus 3 is equal to this. We have to ask ourselves, what x will cancel out 2 out of these 3 terms at the top? So if I set x, for example, equal to 0, look what happens. If I put 0 into here and 0 into here, this one and this one will go away. Where I'm left with 5x becomes simply 0 because 5 times 0 is 0, plus 3 is equal to a bracket 0 plus 1, 0 minus 3. 3 is equal to negative 3a, and therefore a is equal to negative 1. We just found our a value. Now we have to ask ourselves the same thing. What x value will make 2 out of these 3 terms go to 0? Another one that I'm thinking of is negative 1. If I place negative 1 into here, this will go to 0, and this will also go to 0, where we are left with 5 times negative 1 is negative 5 plus 3 is equal to c times negative 1 bracket negative 1 minus 3. It's a simple equation to solve. Negative 2 on the left side and positive 4c on the right side. And so c is equal to negative half. We just found our c value. Excellent. Now we have to find our b value. What x will make 2 out of these 3 terms go to 0? Well, if I set x is equal to positive 3, this will go away, and so will this. And we're left with our b term. Setting x to positive 3, we are left with 5 times 3 is 15 plus 3 is 18 is equal to 3 placed here becomes B3. 3 plus 1 is 4. 4 times 3 is 12. 12b is equal to 18. Therefore, b is equal to 18 over 12, which is equal to 3 over 2. We just found our a, b, and c. That's our a, that's our c, and that's our b. In our last step, we will place these numbers back into here. So our a, b, and c will be replaced with this was 3 over 2, this was negative 1 over 2, and our a, if you recall, was equal to negative 1. We have to find the integral of this function, which is not hard to do at all. The integral of this is equal to ln absolute of x, this negative 1 at the front. The integral of this is 3 over 2 ln the absolute of x minus 3 minus half, write this at the front, ln absolute of x plus 1 plus c. And this right here represents the integral of this function. And there you have it. That is how to express a rational fraction as a sum of partial fractions to integrate. Make sure to watch question 3 for an even tougher example than this.